ninja question reading skills. Because one of the things that I've been talking to lots of people about just recently, because of this now imminent exams, whether you're in year 12 and you've got your end of year 12 exams, or whether you've got the real thing if you're in year 13, lots of people are like kind of, well, I get the wrong end of the stick. I read the question, I don't really know what they're asking for. And what I want to do is I want to point out to you that you've spent 17 or 18 years learning how to skim read, and you have to not do that, which is really, really hard. I'm sure all of you have said before, or had your teachers say to you before, you have to read the question, and then answer the question you've been asked, not the one you think you've been asked. But they don't ever really say to you, how do you make sure that you read the question? Because you've spent, nearly 20 years learning how to not quite read things because you've got to get through things quickly, right? So you've got to deliberately slow right down, and you have to notice everything. So what I want you to do is I want you to have in your hand a highlighter pen, right? You're not allowed to use it in the answers, but you are allowed to use it in the question. And I want you to highlight the word that gives you the clue about what the question is about. So it might be the word circle, or it might be the word momentum, or it might be the word photoelectric effect, or it might be EK max, or it might be C squared with a bar on the top. Those things will tell you what your question is about. Sometimes it says gravitational force, sometimes it doesn't, but highlight that word. I want you to highlight any word that disguises itself, but it's really a number. So the word rest means a speed of 0. And if it says opposite directions, that's the direction of a vector. That's kind of a number, okay? The word squared, proportional, there are lots of them like that. Stationary, that's a number. Okay, you need to highlight all of those. I want you to highlight the command word, the thing that tells you what to do, which might be calculate, or it might be explain, or it might be discuss, or okay, here we go. He's pulling up some questions now, so that we can have a little look.
Can I just say, as you might know, I've got 500 million past paper questions going back to 1975.
About 3,000.
Yes.
Yes.
Yeah, I've got loads of paper ones at home. And what I did when Ali was talking about that, I thought, I'm not going to call her bluff or anything, but I thought I'm going to go all the way through my directory. Here it is, all the way through my directory of papers. Here they are, go woo, like that. And I thought I'm just going to stop at one chosen at random. And I did. And I did. And this is it.
Okay, cool. Like it.
2012, AQA. It's a standard sort of thing. The questions here, you will recognize their style, even though this is 12 years old.
Yeah.
Physics hasn't changed much. We still do mechanics, you still do materials, you still do weight. So these questions are relevant. These are exactly the same questions that you will get. And as Ali was chatting, I was just twiddling through it, and I noticed a few things. So in 1B, there's something there that's quite interesting. Just the one sentence. The word that caught my eye is horizontal. Horizontally through still air. And you could quite easily miss that. Okay, if it's not going horizontally, then there's some strange stuff going on. So that might be a slightly more complicated question. But those are the things I think that you were talking about. Is that right, Ali?
Yeah, it absolutely is, because they don't use unnecessary words in A-level physics questions. Pretty much every word that isn't and of and it and that is an important piece of information. They are very data dense pieces of prose, and you have got to learn to notice pretty much every word. Certainly every word that's not a preposition kind of thing. So can you see how important it is to slow down And holding a pen in your hand and highlighting a word, just like Brian's doing there, is really, really helpful. Right now, if you get to the end of reading a question and you don't really understand what is asked, go back and read it again. Try and make sure you understand what every sentence means before you move on to the next sentence. And quite often, drawing a little sketch of what's going on can really help, especially if it's a force diagram. Quite often, figuring out what the equations are that go with that topic might really, really help. Just figuring out which of the variables they've given you might really, really help. Okay, so here, this one happens to be about refractive index. We know it's about a core. We know it's about an optical fiber. I mean, they're not really in the course anymore, but can you see how there's information there that you and this is what I mean by ninja question reading. If the first time you read it, it doesn't make sense, read it again. And the information is probably there. You just have to slow down, make sure you read every word. And this is why I'm saying highlight those words that are important, because they probably will help you figure out what to do. Probably. That word, proportionality. Can you see? That's an important word. Well, it's actually a whole phrase, isn't it? Limit of proportionality. Okay, so that's where it's not proportional anymore. In other words, it's where the straight line stops being straight.
Yeah, can I point out on Friday when we were going through some questions, the way I do it, as you know, is I talk about some physics and have a typical question, show you how you can do it, look at the mark scheme, and then the examiner's report. And it came up again and again and again. I can't remember the specific questions, but the examiners say again and again, it is surprising how often the candidates don't read the questions. And I highlighted that one there because it's bold. If there is a word in bold, then pay attention, because
they really want you to notice it.
It's not even a hint. It's look at me. And the question, it was a question something like, explain this and that. And lots of people explain this. Fantastic. But they forgot to explain that. And that annoyed the examiner quite a lot, because they put a lot of effort into their questions.
Yeah, it's true. Yes, it's true.
Yeah.
Okay, has anybody brought any questions to go through? Can I just point out that the way you get good at doing A-level physics questions is by doing them. So you've got to have a go. Just have a go. If you're getting stuck, there's a very good chance other people are getting stuck too. So be brave, be what's the word? Stand out from the crowd and say that you've got a question that you'd like to go through, or something. Yeah. Oh, look, Darren's gone with something. Yay. Okay. Sometimes when you look at the mark scheme, experiment questions don't really have an example answer, but bullet points of what you should write about. Does this mean you should do bullet points? Bullet points is fine, actually. When I'm marking papers, I find that marking bullet points is easier. So, I mean, you can do bullet points without actually doing the little dot. So let's do a practice on ninja question reading skills. What is this question about? Where is the clue that tells us what this question is about? Can you see? There it is. So this question is about simple harmonic motion. Right, now it says, what is the phase difference, that's very specific, between displacement and acceleration? Okay, displacement. Let's start with a cosine curve. Okay, so this is with time, displacement. Velocity is the gradient of this one. There, the gradient is 0. Bow, bow. There, the gradient is large and negative. There, the gradient is 0. There, the gradient is large and positive.
Why don't we get sound effects?
There's the gradient is 0.
I'll do them.
I'm sorry.
Bow.
Bow, bow,
I
bow.
do the sound effects.
Okay, so there is velocity. Right, okay. Next one is acceleration. And acceleration, thank you, Maker, is the, this is also a T, with T. Acceleration is the gradient of the velocity graph. So there is large and negative. Sound effect?
Bow.
Yeah. There, the gradient is 0.
Bow.
There, the gradient is large and positive.
Bow.
There, it's 0.
Bow.
There, it's large and negative again.
Bow.
These sound effects aren't very consistent.
Oh, everyone's a critic. Okay, so, right, now, what we want is the phase difference between the displacement, this one, and the acceleration, this one. Right, okay, so how far sideways have we got to slide one of these curves so that it lines up on top of the other one? How
90
far?
degrees, basically. What's the equivalent of 90 degrees on this? Quarter of a phase?
It's not 90 degrees. 90 degrees won't make it line up. Can you see at the moment, the acceleration looks like this?
Oh, 180, because I'm doing backwards. I went from acceleration to x, the other way.
Can you see there has got to move to there, right? That distance. Can you see that's how far it's got to go in order for it to line up? And that is half a complete oscillation. A whole oscillation is 2 pi. Half a complete oscillation is pi. So it is pi out of phase. The reason that I wrote what I wrote in green on there is because you can tell this without doing all the graph stuff. You can tell this just from that equation. Remember what I said about our ninja question reading skills? This is about simple harmonic motion. If you go and look at the simple harmonic motion equations that are labeled simple harmonic motion on your data sheet, this is one of the equations. It's there for you to just go and look it up. You know it's about simple harmonic motion, and there it is. A is the acceleration. X is the displacement. A is equal to X, but in the opposite direction. So whenever A is going up, X is going down. So from that equation, you can just easily draw, well, if that's X, my A has got to be the other way. That is now A. So can you see how far have I got to slide it in order to get one to map on top of the other? Can you see that that equation tells you that they are pi or 180 degrees out of phase? Oh, apparently Brian would be great in a band.
That's a lie. That's a lie.
Questioning what kind of band?